Okay. So what is this all about? I suppose you kind of understand what this infix, prefix, and postfix stuff means, right? Do you understand what it means? Okay, so I want to in is sort of inside, right? That you can understand. Pre is before, exactly. Yeah, post means after. So what we have learned in school, this is an example of infix expression, isn't it? You kind of see what it means, right? This is what we learned at school, right? You guys, when you have math class, this is what you learn at school. And what this kind of expression, there's the rule of operation is that you have an operand and an operator and then an operand, right? That's how you write expressions. And but then there's this set of precedence rules that we also have to learn, right? We all learn this at school. So like in this expression, 1 plus 2 minus 3 times 4 plus 24 divided by parentheses 5 plus 1. In this expression, the first thing you do is whatever is in the parentheses, right? And actually there's another rule. Somebody has a question. Is this also what M does? I'm not quite sure what that means. Exponentials, right? If we have, sorry. So infix, and when we have exponentials, we do exponentials, right? But we don't have that in this particular one, so we don't have anything there. Oh yeah, okay. Okay, that's, yeah, exactly. That's the precedence rule, right? So you do parentheses first, and then you do exponential, then you do multiply and division, multiplication and division, and then you do addition and subtract, right? So these are the rules that we have to follow. As humans, it's not too hard, right? You kind of, I mean, you have to, learn some of these tricks to remember these rules, but they're not too bad, right? They're not too hard. I mean, after a while, you get used to it, and then you know how to do these math, right? These are, relatively simple rules. But consider that computers are not so smart, right? Computers don't have this learning capability. So whenever you have these rules, what that means is that when you do this kind of operation, when humans work with computers, right? Humans would write expressions like this, right? 1 plus 2 minus 3 times 4, and so on and so forth. And then we would expect computers to, understand that and follow the rules of humans, right? Follow our rules to, solve that expression. But like I say, computers are not so smart. Computers are, I mean, you you have to tell them what to do exactly, right? And so in computers, if you have to, use these rules, follow these rules, then you have to, write code to parse this expression so that you can follow these rules, that you can, so you don't get, a result from the computer that is different from what humans would have, right? So these simple rules are not so simple in computers when you have to write code to, because these code have to be generic. Generic meaning that you write an expression, right? This is one expression, you have to do it this way. And then somebody write this expression in a different order, right? But you still have to follow these rules. And then the expressions are generic, meaning that sometimes you can have variables in here, you have, different kinds of values in here. And however that expression is written, the computers needs to understand all that. So, and in early computers, right, these are not so simple rules for computers, right? I mean, people have to create all these software to understand all these expressions. So there are ways to, to write expressions so that we don't have these rules, these precedence rules. Okay, so that's where this prefix expression comes in, right? That same expression that we had earlier. When we put it into prefix format, which is, right, you always write an operator first, and then you have two operands that follows it. Right, this is, when you have operators that with two, usually operators work with two operands, right, in our expressions. And so in this one, right, in this particular expression, what we can do, what we can see is that there are parts that follow this format, right? Follow this notation. For example, here, plus 3 and 4. Right? In that case, we can resolve that. Right? When we work on this expression, we can resolve that immediately, which gives us 7. Right? And then what else we have? Plus 5, 1. Right? We can resolve that immediately. We get a 6. Right? And then after that, we have divide 24 and 6. Right? One operator and two operands. And so we can resolve that. We get a 4. Right? And after that, we have multiplication, and somebody else came in. Right? So we don't have any precedence rules, right? We don't have parentheses. We don't have all that. And if we have exponential in here, we follow the same rule, right? If we have a exponential and then two numbers, we do exactly like that, right? Right. So we can do this exactly with the exact simple rule, right? Operator, operand, and operand, and you can do it, right? Okay, for the one who just joined us, we'll go back real quick. Right. This is this week's content, which is prefix, infix, and postfix notation of math expressions. Right. Because in computer programs, we do math a lot. And infix expression is what we humans know about, learn about, right? When we start in elementary school, we learn this, right? 1 plus 2 minus 3 times 4 plus 24 divide by parentheses 5 plus 1. And in this kind of the expression, in this kind of expression, we have operand and then operator and operand, right? That's kind of how we write these kind of expressions. But then, right, with all that, then we have to follow these precedence rules, right? Ryan gave us that acronym PEMDAS, right? PEMDAS, which is, you have to do parentheses first, and then exponential, and multiplication, division, and addition and subtraction. Right? These are the things we learn, we as humans learn, from starting from elementary school, right? When we learn these simple math, and then, anything after that, it's just math formula expressions become more complex, right? But the rules are still, those rules. When you follow these rules, everybody understands, what you're doing. But for computers, right, as we say, computers are not humans. They don't have, these kind of learning capabilities. Although nowadays and afterwards, computers do have this concept of artificial intelligence, right? Computers do have some learning, but humans have to program all that, right? Create all that software, create all these rules, these tools to, understand what you humans mean, right? When you write those kind of expressions. And so in some programming environment, or actually this is this prefix notation is actually invented or created by a Polish mathematician, right? So he invented this notation so that you write an expression with operator leading to operands, right? In this format, then you'll always, right? Then you can always do things in the exact way that these these expressions are written, right? And so in this case, when we write this expression in this way, then when we look at the expression, right, we always see if we have an operand leading to operand, and we can do that calculation, right? Perform that operation right away, right? Without having to follow other rules. Like there's no parentheses, and there's nothing that says you have to do multiplication before you do addition here either. So the only thing you have to follow, the only rule you have to follow is that you have to have one operator and two operands, right? So following that rule, you can just go one step, step by step. Then you can, resolve that expression, right? That's prefix expression, prefix notation math expression, right? And here, when we have a infix expression like that, right? This means x equals in computer programming, this is assignment, right? Assigning this expression value to the variable x. And AB means A times B, right? And C/D means C divided by D, and then exponential of that whole thing. All right. So here's what we do with this conversion, right? This is actually that whole expression, right? When we, explicitly write everything down with all the parentheses, meaning to indicate what we need to do first, right? So in this whole expression, what we need to do is do this first, right? A times B first, and then C divided by D, and then the subtraction, right? And then the exponential, right? And then the whole value assigned to x, right? So when we put all these variables down here, right? All these values or variables, each one of them has their own value, right? And now we can say we have to do A times B first, right? So we take that multiplication and put it right here in front of A and B, right? That means we have to do that first, right? And when we got to the end, you will see that that will happen first also, right? And then what we do next is C divided by D, right? So we take that division and put it right in front of C and D. Does that make sense? Right, because if you now evaluate this expression, you can see that this has to happen first, right? And then this has to happen, right? Because these are the only place where you have an operator leading to operands, right? And then that subtraction, right? We put the subtraction right in front of these two items, right here. So if you look at this, nothing else, what you can see still is this will happen first, right? This will have to be evaluated first, right? And this will evaluate next, right? And then the only operator left in this expression is this thing, subtraction, right? So this subtract, right? That's exactly what this means, right? But in the prefix notation, right? And then what happens next is the exponential, right? You can see A times B, that, and subtraction, and then exponential, right? So the exponential, which is, in ACSL notation, that's what means. That means exponential. So we put that in front of the minus sign. That's what we do next, right? And then after all that happened, we do the assignment, right? We put the assignment in front of x because that's one operand, and then the rest is the next operand, right? Because when you evaluate this, you will see that you will have an operator, right? So you can't do anything with all these until you see an operator with two operands, right? So that gets evaluated first, right? And then you go further, you see one operator and two operands again, and that's get evaluated next, right? And then you have this becomes one operand, this becomes one operand, and this becomes another operand. 3 operands, you can operate that, right? So you go back, and then you hit the exponential, right? Exponential, you have, no, you actually hit the minus, right? The subtraction. The subtraction will work on this item, right? And then this, basically, it's this subtract by that much, right? And then that becomes one operand, right? And that one operand, and the next operand is E, and the operator is exponential, right? So that's basically what that expression is, right? And then you evaluate that, and now this becomes one operand, this is one operand, and the operator is the assignment, right? So that whole expression gets assigned to X, right? So this is how you convert from an infix expression to prefix. Right? This kind of these are the kind of problems we need to solve when we go into ACSL. All right, and a postfix is basically exactly the opposite of prefix. Right? Prefix basically means the operator is in front, right? Before the operands. Pre means before, right? As what's your name again? Ben? Yeah. As Ben just told us, right, earlier. So you have operator before operands. That means prefix, right? And postfix is basically the opposite of that. And so you have the operator after the operands. But the meaning is exactly the same, right? So you have operators always follow the operands, and then that's the only way you can operate, right? You can resolve that that part of the expression, and there's no other rules, right? No precedence rules. And so here's an example, right? This example is the same as the prefix one, right, earlier. But we basically have, you know, operands and then operator, right? So in here, we have 2 operands and 1 operator, and then we can evaluate that to 7, right? And then here in this expression where we have situation like that is this, right? 5, 1, and then addition, right? So we can evaluate that, becomes 6, right? And then in this expression, where we have operand operator is this, right? 24, 6, and division, right? And then that gets evaluated to 4, and then the remaining is 7, 4, and multiplication, and we get the same result, 28, as the prefix notation gave us, right? So without any other rules, right? Just following this, right? Just following the postfix rule, we can evaluate the expression, right? And so infix to postfix expression is exactly the same as we did the prefix infix to prefix conversion, right? It's basically when you have this infix notation, infix expression, right? When you write it down with everything explicitly written down, right? So this is exactly how we would evaluate this whole expression, right? We talked about that earlier. And so now we do this first. We just need to take the operator, the multiplication operator, and put it after the operand, right? And here too, we put the division after the two operands, C and B. And the next one, the next operation is this minus, right? And we put that minus after these two components, right? And the next one is exponential, right? The exponential operates with everything that comes before that, this evaluation and the E, right? So it's all this A times B minus C divided by D, and then to the power of E, right? And then all that value gets assigned to X, right? If you look at this, it's basically, right, the reverse of how the prefix operation, prefix expression were done, right? So in here, this basically gives us the steps that we have to take to evaluate this thing, right? So that's how, I mean, these are how we do this kind of, you know, infix to prefix or postfix conversion. And then if we need to convert it back, we just need to follow the same rules, right? If we need to convert this back into this, right? If we don't look at that, if you look at this, you'll go through this expression, you'll find A times B, A, B, and operator, right? So you can do this first, and then this, and then the subtraction, and then the exponential, and then at the end, the assignment. But you can follow this rule back and get this expression here, right? That's what we have in there. And so these are the kind of problems for this category of ACSL contest. And so why do we do all these, right? Actually, we've talked about this already. The reason is basically the order of precedence rules are complex. Complex meaning, although not necessarily for humans, right? But still, it's a set of rules that you have to remember. But for computers, you basically have to program all that parsing. Parsing meaning that when you look at the expression, right, you have to pick out parts that you have to do first and do all that. And so you have to divide computer algorithms, right, to parse these expressions before you can solve them. And prefix, postfix expressions are, you know, you don't need much parsing, right? You just need to, you know, just work on these things as they appear, right, as they show up. And also they work well with some data structure. Data structure meaning that, you know, in computers, everything is binary. We talked about that, right? So everything are just, you know, bits, right? But how do you turn all those bits into something that, you know, like our computers nowadays can show all these on the screen, right? Can do all these wonderful things. And how we do that is we turn these bits into structure, the unstructured bits into structured stuff, right? So postfix and prefix expressions work very well with things like stack. And stack is something that if you have a bucket, right, like this, and you put something in, you can put multiple things in there, right? And when you want to take them out, you have to take the top one first, right? you can only get to the top one because this is like a barrel. And, there's no way for you to dig into it to get the bottom, right? You have to take out the first one first, top one first. So those are the kind of data structures that work very well with these type of expressions. So when you have expressions written in prefix or postfix format, then you can do them. You can evaluate them much more easily, right? So prefix to infix expression, for example, this one, right? So when you take a look at that, you can see that there are parts of it that meet the prefix condition, right? Requirement. Prefix, yeah. What is a prefix, right? So in here, I'm using the colors to mark out the parts that you can work on, right? So when you go through this expression, you can see that 3, you can have the multiplication 3 and 4. So that can happen right away, right? First. So that happens first. And we'll just use parentheses to mark the parts that's already converted, right? It's already done. So this can happen first. And once we get to this, and the next part is this one, right? This one, we can put them in parentheses like that, right? And then the next can happen is plus that part, right? Or we can do this also, and that probably doesn't matter that much, right? The order of that. But let's do this, right, first, because this is, you can look at this as one operand and this as one operand, right? Then you can convert that part, right? And then the next piece can happen is this, right? This is a prefix expression, right? So that becomes this, right? 7 minus 7 subtracted by 5. And now the next thing can happen is, this is complete. This is complete, and the operator is exponential, right? And so that becomes this, right? So that expression now is fully converted into prefix. I mean, the infix format, right? And now we can, as humans, we can do that quite easily, right? We kind of, our brain is programmed to do this, right? Does that make sense?
Yeah.
This kind of, conversion back and forth. And so postfix, it's pretty much the same thing, right? Postfix means that the operator is after the operand, right? And you basically look at that and you find 2 operands, and then on an operator, you can just convert that, right? And then you find this, you convert that, and then you find these, right? You convert that, and then you find this, you convert that, and then right, the end, we get the same result in this infix notation, right? And after we got to this point, we can eliminate some of these parentheses, right? Because again, there are precedence rules that help in that regard. And so let's do some practice. Yeah, let's work on this one. All of you that are on Zoom, please work on this conversion. Not conversion. Well, yeah, you can convert it or not, but put those values in and get the result. All right. Need a pen, pencil? Mm-hmm. Here. There are there's a pen here. Here. Oh, sorry. Okay. Hmm? Actually, I don't know. We can work on this after we're all done. Thank you. Mhm. You're done? Are you done? No. How about you guys on Zoom? Are you guys done? If you are done, you can chat me, send me a chat on the on Zoom, and we'll reveal that in a minute. Hmm? Sorry, I didn't hear you. Say it again.
What should I do?
Oh, what should you do?
Like, what do you give me the practice problem?
Yeah, we have more practice problems.
Okay.
I don't know if you guys want to take a break for 5 minutes.
Sure.
We're going to take a break. Let's take a break. Anybody still there on Zoom? Good. Okay, I think. Continue?
What?
Want to continue?
Sure.
So I got one result back from Zoom on Zoom. I think I did resolve this probably. Oh. Nope. Okay, so we didn't resolve this in the slide. Excuse me. We'll do this here. Let me stop sharing. And then using this. Let's see. Okay. This is how we resolve that, right? And so that's here's the expression to begin with. And then we put the values of A, B, C into that, right? So A is 2, B is 4, and C is 8, right? By following the prefix, right, prefix expression rule, right, we are able to evaluate that, right? So when we put the values in there, and we can look at what we can operate on, right? Prefix needs to have operand, operator leading to operands, right? So this part, we have multiplication and then 2 numbers, right? So we can work on that. That gave us 32, right? And then this is also an operator leading 2 numbers. We can work on that. That gave us 10, right? And now this is the expression. And in there, we again have the plus, the addition leading 2 numbers, right? We can do that. That gave us 34, right? And all the rest are the same. And after that, we have this subtraction with leading 2 numbers, right? We can work on that. That gave us 24, right? 34 minus 10 is 24. And now the result is 24 plus 8. That gave us 32, right? Okay, and so let's work on the next one is this. And this is an infix expression, right? We need to write this out as in postfix format.
That's good.
Yeah, you could do that. Oh, I forgot to share this. Share my screen.
This matching with
Yeah, but you'd have to remove all those parentheses, right? In Postfix, we don't have parentheses anymore.
Well,
What is the A?
8 times, right?
what's the what do you use times or should they use about asterisk?
Sorry, what?
Should you use like the times symbol or the asterisk?
Yeah, you can use the star, right? The asterisk. Is that-
If it's multiplied, then I got the whole thing wrong.
Not necessarily. There has to be an operator, right? There has to be an operator in there somewhere. There's A B plus D, that means 8 times parentheses B plus D, right? That we like in the earlier ones, in this, oh no, yeah, this one is the same, right? When we say AB, it's A times B. You can do that, or the other way to do it is to, just leave.
If you give this the final exam, does that?
Yeah.
Is that?
That would count. Yeah, I believe
So
it.
there's like 2 ways to do it, but this is the more like computer.
Yeah,
Wait.
Yeah. right. This is how we did earlier, right? This AB is basically A times B, A multiplied by B. So we use the same. Yeah, this is the one. Yeah, this is the one. So it's A times B plus D divided by C minus E. Okay, I don't know if you guys on Zoom, did you work on this? Okay, we'll continue from here and you're done? Also, okay. So I guess this would be let me do that. Is that in a okay. Wouldn't go any bigger.
No, this doesn't become
Oh, I have to stop sharing it. Okay. So if I stop sharing, then this is This is that original expression, right? And I guess in the ACSL way to do this, we write all the operands down here, right? And then we figure out what we do first and second, right? First we do B plus D, right? So I kind of skipped a couple of steps, right? First we do B plus D, and then we do C minus E, right? And so for postfix, we just put there the operator after the operands. And then we do what? The multiplication, right? A times B plus D, right? So we stick the multiplication operator there. And then we do the subtraction, right? I mean, not the division, right? And so basically that's it. That's the result, right? Or as Ben have done, you can also do this. I suppose ACSL should accept that result, which is basically you do B plus D, right? First, and then you do C minus E, right? And then you do the oh yeah, you do A times hold on. You do B plus D first, and then you do A times that, right? And then you can do C minus E. Or, I mean, if you strictly follow the rule of parentheses first, and then in that case, you would do C minus E, right? But and however you do it, I mean, the result would be the same, right? And then you do, at the end, you do the subtraction, right? Because you could have, but anyway, yeah. I mean, the result would be the same as long as you follow the postfix rules, right? And now let's go back to screen sharing again. This one. Evaluate this. So yeah, there are a couple of explanations here. You know what these are, right? Greatest common factor and the least common multiple. Right? You know what that is, right? Greatest common factor meaning that here between 12 and 18, right?
That's so
Yeah, okay. The largest factor in those two, between those two numbers. Yeah, and then like the least common multiplier, multiple, not multiply, multiple of those two numbers, right? And basically, you can just write this expression down, and then as you evaluate them, you can just, write an underline, draw an underline between the operators and operands, and then the rest of them you just copy down and one step at a time. Mhm. I think so. This is a problem from
My answer is D.
an actual test, contest.
So my answer is D.
Yeah.
I'll explain it.
Okay, let's do it. Let me stop sharing. Let me copy this down first. So the expression is exponential division, multiply, and the GCF, right? 12, 18, pound, 2, 3, exponential, exclamation, 6, 8, 2, 9, 15, right? Okay, so let me stop sharing here. So we can look at this. Okay, so we can look at this. Look at this, right? This is the expression, right? Because this is what prefix, right? This is prefix, so we have to look at them and see which parts we can evaluate. This, right?
Please contact us 6.
And this,
No, please contact us.
and this, and this, right? We just look at it and we don't have to, literally do it one step at a time. We can do multiple of them at a time. This is 6, right? As Ben says,
6,
and this is also 6.
2,
You understand what this means, right? This is the least common factor, or greatest common factor, and the least common multiple, right? Because these two are both prime numbers, right? So the common factor is basically the multiply of both of them. And then these two, right? And these 3, right? And so the rest will just copy down. 2, multiply, right? And now we can see what we can do here, right? So this is 36, right? And this is 4, and this is 3, and divide and exponential, right? What we can do next, these, right, would be 9, right? And then 9 to the power of 3, right? That gives us 729. Right? Does it make some sense now? So as I say, when you do this at the contest time, you can just do it like I did, right? Just draw them, draw an underline between the under the parts that you can work on at that point. Right? Does that make sense? Right. So when you draw these parts, you can just resolve that part, and then the next expression, you can just see what you can resolve again. Right? Just underline the parts you can resolve at that step, and then step by step you should get your result pretty quickly. Does that make sense?
Yeah.
Okay, good. So let me do screen sharing.
不要乱动啊！
傻逼。
现在明白了吗？就是先算这个 greatest common，
Oh, and
Factor.
then you do the rest.
然后对，然后一步一步做嘛。然后就是这个乘以它，对不对？
And then it's 9 to the power of 3
对
at the last part.
对啊，就是一步一步这么做。
And then you get like 81 times 9.
对，
Oh, wait,
Oh, come on. I think it's gonna crash. Zoom is gonna crash.
Well, in your lab,
Does that sometimes? I have no idea why. Okay.
that's quite true.
All right.
Well, we're
Shit.
close enough for what you said. Well, I think
Oh, come on.
it's better for the sound that bad.
The new icon always blinking.
Okay. All right. So this is somebody type something in chat. Let's see. Oh, no, that's fine. Is that the what we're talking? No, okay. So the result is B, right? 729. 9 to the power of 3. Let's see. Do we have some more? Nope.
No.
We have let me check. That's all the lecture part for this session. Okay. What we are going to do now is we actually have a, let me see, where did that go? Here. Okay. This is a real competition thing. So let's do this. Nice. I'm still sharing, right? Yeah, I'm still sharing. So you should be able to see this on the remote site. And let's finish this one. 5 problems. In this test, the question number 2, this angle thing is exponential, and the rest of them too.
2. That's weird. I wonder if check it, is that like one of, is it like this? Is it two very, it's two actually. If there's negative or it's.
Probably,
We'll double check it.
yeah. These are two numbers. This is not 23. This is 2 and 3. I guess it's hard. All these are individual numbers. 2, 3, 7, 1,
Oh,
and 5, 2. It's not 52, not 71.
is that like blue? Is that us? Let's come up with it.
Let me know when you're done. Um, mhm. Take A. You write your name on it?
Is the rest correct?
Hmm?
The rest correct?
Yeah, I think so. I just have a division in there, right?
And then is it not supposed to be a division?
No.
Yeah, this is.
Yeah, okay. That's what I was trying to guess.
Well, the reason why I don't use it like this, because it's actually, it can be mistaken as a one. So let me take a picture of it. So let me take a picture of it.
Thank you.
Okay. Where do you go?
Yeah, do you want me to go through this?
I don't even know how to do that.
Okay, your parents here?
I can write it down. Oh, I think you could teach me.
All right. So, you done? No? Okay. I guess we're out of time. But if you guys want to go through this, let's go through this very quickly. Okay. So number one. So question number one. Again, I basically underline the parts that I can work on immediately, right? So 8 plus 4, that's postfix, right? So 8 plus 4 I can do immediately. And 5 minus 5, 2 subtraction, I can do that, right? So we get 8 plus 4 is 12, and 5 minus 2 is 3. And then the rest of them would just copy down, right? Multiply 2 and divide. And then 12 times 3, right? 12, 3 multiply is 36. And we got 2 and divide, right? And so we got 36 divided by 2 is 18. Right? And the next one is basically the same, but it's prefix, right? So prefix, again, we underline the parts that we can work on right away. Right? So that is addition 2 and 3, that's 5. And addition 7, 1, that's 8. And exponential 5, 2, 5 to the power of 2 is 25, right? These should be relatively easy. And then the next line, the other stuff we just copy down, right? We have plus 8 minus. And now we got what? Multiply, right? Multiply 5 by 8 is 40. Right? The rest we copy down again. Plus 8 minus 40 and 25. And so now what we can work on is minus 40 and 25, right? That's 15. So we got plus 8, 15. That's 23, right? So basically, that's how you evaluate these things. The next one is converting that into prefix. I just did it in one step, but I made a mistake here. You can see that, right? So basically, what you do here first is 4 times 5, right? We write 4 and 5 down and put the multiply in front of it, right? That's prefix. And the next thing is 6 divided by 2. We write down 6, 2, and put the division in front of it. And then the next thing we do is 3 plus, right? 3 plus this part So we put plus, the addition in front of those two terms, right? And then we do the subtraction. Again, we put the subtraction in front of everything. This is prefix, right? So there you got the prefix. And the other, that conversion, again, is the same thing. We just copy down all the operands and then do them, in the, in the way that I'm supposed to convert it to postfix. I made a mistake there. So I copied it down here, 3, 4, 5, 6, 4, 2, and 2, right? So now I'm going to do that postfix thing, right? 3 plus 4, gonna do that. So we put plus there, and 6 plus 4 here, plus, right? And what we do next is 5 times all that. So I put the multiplication here, and then the division here. So the 2 here and the division there, right? And then we do the subtraction of that whole thing, right? So the subtraction goes after that, and the rest is 2 and exponential, right? And the last one is pretty much the same, right? We just, mark the parts that we can work on, right? So this is first. After that, we can do this also, this regardless, right? We can do that. And then after that, we do this, and after that, we do this, right? So we just, copy it down, and then we put the, we take the operator in front of the operand and put it after, right? And then when these two parts are done, we do this, right? Multiplication, but after these terms. And then we do the divide by 2, right? 2 and divide by, that's there. And then we do this exponential, right? These two are the exponential only works on these two, right? So we do the exponential, and then the last thing we do is the subtraction, right? So got to remember all these rules. Just basically which one goes first, right? What part you go first. And in prefix, you look at the operator in front of the operands, right? And then in postfix, you put the operator after the operands. That's it. Thank you very much. Okay, cool, thank you. All right, you guys have a nice weekend. All right,
Thank you.
thank you.
Bye.
Bye-bye, have a nice week.